So let's just see how we can insert a new node at a particular position in the circular doubly linked list. So currently we have 3 nodes in the list. Now let's just see how we can insert a new node with a particular value at the beginning of the list, in between the nodes, or at the end of the list. So here we're going to write the function to insert a node at a particular position in the circular doubly linked list. So the function will return struct node type pointer. We're going to call the function insert at position. So the function will take head pointer, and also we're going to pass the data, and also we have to pass the position where we wanted to insert this new node. So first of all, let's just create the new node. So let's just call the function create node, and we're gonna pass the data. So that means we have created this new node. Now we have to insert this in our list. So first of all, let's just see in the case where the list is empty. So if the head is pointing to null, that means the list is empty. So when the list is empty, that means we need to insert this single node in the list. Now because this is one single node in the list, so it should have the self loop, so its next pointer should point to itself, and also its previous pointer should point to itself. So here the new node's next pointer should point to the node itself, and also the new node's previous pointer should point to the new node itself. And now we're gonna return this new node as the new head node. So that means the head pointer should point to this newly created node. And this is the way we can insert a new node when the list is already empty. Now suppose the list is not empty, we have multiple nodes in the list. So in that case, to insert this node at a particular position, first of all, we need one temporary pointer which will initially point to the head. So here we're going to create the temporary pointer which will initially point to the head node. Now suppose if the position has a value 1, that means we have to insert the new node at the beginning of the circular doubly linked list. So if we wanted to insert this node at the beginning of the list, so in that case we have to shift this temporary pointer to point to this last node. We have to shift this, so temporary pointer should be shifted to the head node's previous node, so that we can set links from the last node to this newly inserted node. So the new node's next pointer should point to the head, and its previous pointer should point back to this last node. So the new node's next pointer should point to the head, and the new node's previous pointer should point back to the last node, which is the temporary pointer. Similarly, this last node's next pointer should point back to this new node, and also this head node's previous pointer should point to the new node itself. So the temporary pointer or the last node's next pointer should point to this new node, and also the head node's previous pointer should point to this new node. So that means all the links have been set with this new node. Now we have to make this new node as the new head node. That means the head pointer should point to this new node. So here we can return this new node as the new head node. And this is the way we can insert the new node when the position is 1. Now suppose the position is not 1. In that case, we have to traverse to that particular position. So we're gonna use the counter. So the counter will have initial value 1. So here we're gonna use the while loop, and the condition is, so the loop will continue as long as the temporary pointer next node is not equal the head node, and also the counter should be less than the position minus 1. And in every iteration we're gonna shift the temporary pointer to the next node, and also we're gonna increase the counter value. So that means we're going to shift our temporary pointer in each iteration, and the counter value should be less than the position. That means we wanted to reach before the insertion position. Suppose we wanted to insert the new node in between this 200 and 300. In that case, the temporary pointer should point to this node 200, so that we can set the link from 200 to this new node and 300 to this new node. So when this loop ends, our temporary pointer will point to the node before the insertion position. So now all you have to do is we have to set the links between these nodes. That means the 200 should point to this node, and the 300 should point to this node, and also this node also should point back to these new nodes. So we need another temporary pointer, so let's just call this last. So it will point to the next node after this temporary pointer. So we're gonna create the last pointer which will point to the next node after the temporary pointer. Now we have to set links between these nodes. So the new node's next pointer should point to this last node, and the new node's previous pointer should point to the temporary node. So that means the new node next pointer is pointing to this last node and its previous pointer is pointing to the temporary node. Now the temporary next pointer should point to this node and the last previous pointer will point to this node. So the temporary next pointer should point to this new node and the last node's previous pointer should point to this new node. So here all links have been set. Now we can return the head pointer after the modification. So here currently you can see in the list we have 3 nodes. Let's now insert a new node at a particular position. So let's just call the function insert at position, and first of all we're gonna pass the head pointer, then the data like 400 and the position. So first of all let's just insert at the position 1. So it will return one new head pointer. So let's just print the list again. So here you can see the node 400 inserted at the first position. So let's just insert this at the third position. So you can see the node 400 inserted at the third position. So this way we can insert a new node at a particular position in the circular doubly linked list. So hope you understand the concept. See you in the next one. Take care.